About that, folks. This presentation is actually all in Windows anyway, so we're booted into Windows now, and the projector's happy. Okay, so thanks everyone for coming. I hope everyone's having a great conference at DEVintersections. Today I'm going to talk about C# 7 and beyond. It's a tiny bit different than the talk title, so hopefully everyone's happy about that. My name's Rich Lander. I work on the .NET team at Microsoft. We do C#, F#, VB, we do .NET Core, we do .NET Framework. We work super closely with other .NET vendors, and so that's what I work on. Here are my Twitter and GitHub handles respectively, although I just noticed there's a 0 missing from the Twitter one, unfortunately. Okay, so we've been working on this platform for a super long time, and there are other languages and platforms in this space, and I wouldn't exactly say that we think that we're in direct competition with them every single day. But then again, when there's a survey, we always like to know where we kind of finish up, and if the surveys tell us that we should do work in some areas to do better. And so there was a Stack Overflow survey on various things this year. And so one of the metrics was around most popular languages. So C# actually came in a pretty good position, particularly since one of the platforms above it isn't even a programming language. And I'm not talking about JavaScript. And so we're pretty happy with this. It means C# is used pretty widely in the industry. Certainly, Stack Overflow is a biased group. If you went to a completely different group, you might get a different answer. But this is nice to see. It means that C# is alive and well. And then there's another one, which is most loved languages. Obviously, these are two fairly different metrics. And you can see C# is also on this list. And what's kind of cool about it is there's actually only three languages and platforms. Node.js isn't exactly a language per se. It's obviously kind of a proxy for JavaScript. And so these three are the only ones that were on the other list as well. So feel pretty good about that. Obviously, there's a whole set of things below this. The other aspect is that the languages above C# are largely niche languages. That's not a criticism. Some of these languages are actually growing quite quickly. The major point is that C# is basically the only language that is loved to this level that's kind of like a direct industry peer. So we're pretty happy about that. It just means that the platform's doing pretty well. F# shows up here. We work with F# folks quite often. They are indeed a super passionate group. It is fair to say that they are more passionate than C# developers on average. And it's kind of interesting, like F# is to C# as Scala is to Java. And it's nice to see F# just kind of a hair above Scala on this list. F# is something we continue to invest in and try and make better. There's a kind of coordinated language innovation across the two languages, and I guess that's working. Okay, enough of that. So if you've been watching closely, you've probably seen that we've been changing our tune at Microsoft. You've probably seen a much bigger degree of openness with the way we do development. Most of that's related to our open sourcing, but there's more than that. So in the past, if you ran on Windows, then C# was a great choice for you. You could build server and client apps with it. If you wanted to use C#, then you also had to be on Windows. So the two kind of went together. Today, you can run C# anywhere. You can run it on Windows. It's still the premier programming platform on Windows, but you can also run it on Mac and Linux, iOS and Android, and just a whole host of other devices. It's pretty exciting, actually. In the past, we had what we call black box compilers. So the idea was they just did one thing. The only way that you really interacted with them was either through Visual Studio or through command line, but that was it. And today now we have open compiler APIs with Roslyn, and so the compilers have been completely opened up. You now have the same access to the Roslyn API that we do, building Visual Studio, for example. And so, you know, you can build a business building tools on top of these Roslyn APIs, which is kind of exciting. And people are doing that. I talked about Visual Studio. Visual Studio was the only choice before, more or less, if you wanted to do C# development. Now there are other choices. Certainly there's VS Code, but also we have plugins available for a bunch of other editors. So you have a lot of choice, particularly if you're not running on Windows. And last, our whole platform was proprietary and closed source before. Proprietary also in terms of licensing. And so there's only so many things you could do with it and kind of stay within the confines of what we allowed. With this new world, with all the code being open, you can look at it, you can fork our repositories, you can make pull requests on our repositories, you can kind of do anything you want. You can actually make your own Roslyn, and if for some reason someone wants to pay you for that, then go ahead. Okay, just talk about a couple of the kind of, I guess, newer-ish platforms that are available and what you can do with them. So Xamarin's a really exciting one. If you've been watching, you'll know that Microsoft acquired Xamarin earlier this year, I think in April. And so there's a lot you can do with Xamarin. You can build iOS and Android apps, Mac apps, and kind of Windows apps. You can build them for the phones, tablets, for the watches. You know, if there's some kind of car integration, then you can do that too. Basically, the team at Xamarin makes sure that whenever Apple and Google, because that's pretty much who they track, whenever Apple and Google releases a new SDK, like tvOS, that's another good example, they make sure that there's APIs available and tools for you to target those operating systems, just like the folks who use Objective-C and Swift, which is great. So the basic model is that all the APIs are exposed to you. You know, there are other kind of toolkit solutions like Cordova that don't do that. So you have exactly the same set of APIs as an Objective-C and Swift developer would have. So you can code against the UI, you can code against the sensors, you can code against local storage, whatever those APIs do. And then you can take your C# code and your C# skills that you've always had and go use those within those apps. So if there's some particular library that you guys build in your company that's kind of germane to your workload and domain, you can run that in one of these apps. It's really exciting. So one of the previous downsides of the Xamarin product was that it was quite expensive. And so there were a lot of people that thought it would be a good thing to use, but just couldn't afford it. And so Xamarin now comes with Visual Studio. There isn't an additional price you pay. It even comes with Visual Studio Community. So there's really nothing stopping you from trying it out. It's based on Mono. This isn't particularly important, but it's a different runtime than the one that's in the .NET Framework and the one that's in .NET Core, which I'll talk about in just a second. It's really the first open source .NET runtime. It shipped, I think, in 2003-ish. And so it's kind of a .NET Framework clone. That's not meant in any kind of a critical way. And so in more recent years, it's been, what's the word? You know, customized and for these kind of workloads, so it works really well there. Another one, and this is the last one of these, is Unity. So it has similarities to Xamarin in some way. It also runs on Mono, but instead of targeting apps, it targets games. And you may not have heard of Unity, but it's actually the most popular indie gaming platform in the world. It's pretty much the only solution for AR and VR. All of the major AR and VR vendors have Unity solutions. I actually go to gaming conferences, and whenever I do that, I go talk to the more indie developers as opposed to AAA developers. And I would say like 90+% of them use this solution. It's really exciting. It's massively cross-platform. I think they're on about 30 different platforms, some of which I've actually never even heard of. but if you're a game developer, then that's really important. Okay, last one of these. .NET Core, this is actually what I work on. So it's this new platform that we've been building for modular applications, high performance, lightweight. You know, one of the reasons we started building this is our customers were coming to us and said, you know, we're transitioning to Linux, we still want to use Azure, tell me what the dev platform is that we should use. And you know, even though we're in developer division at Microsoft, we didn't really have a good solution. So a few years ago, we started building this, both for our existing .NET customers and also for folks that really always wanted to use C#, but just couldn't on the operating system they were using. Another interesting thing is containers. Docker is a really important trend in our industry right now. If you're building server applications, and so we have Docker images available for .NET Core. ASP.NET Core is the web framework that that most people use on top of .NET Core. Let's tell you two things about it. The first is, or in terms of how it's different than the ASP.NET that came before. The first thing is that before, the web service model and the website model were very similar, but actually different. They weren't type compatible. With this system, it's all completely integrated. There's really no difference between web services and websites, so that's good. And then the other one is there's been a huge focus on performance. The numbers that we are seeing are incredibly a lot faster than what ASP.NET had before. There's some benchmarks that are probably going to get released next month. Yeah, this is October. I think you'll be impressed. It's open source. I kind of already covered that. .NET Standard, you might have been hearing about that on our blog posts, and we've kind of been talking about it. It doesn't really have anything to do with .NET Core per se, but we've been getting customer feedback that says, you know, I really love that you guys are making these platforms available for, you know, other operating systems and other workloads, but you didn't give me the APIs I want. So we kind of finally heard the message, and so .NET Standard is a spec. It's the minimum set of APIs that you need to have in a platform to be considered compliant with .NET Standard. And so we are going to make sure that all of our platforms going forward meet this. We've gotten a lot of positive feedback on it. We've published the set of APIs that are going to be in this. It's at github/.net/standard if you want to go take a look. And we think this is a good new direction. OK, back to C#. So I'll just talk a tiny bit about Roslyn. So Roslyn, that's these open APIs that I talked about before. What this is really, you know, an engine for processing C# code and exposing it as an API. So I talked about all these other, there were Unity and Xamarin, and there's some other folks too. And Mono, for example, they actually had their own C# compiler. And so we were kind of getting this position where we were actually increasing the innovation or speed of innovation in C#. And so there would be the friction of when those, you know, C# keywords and concepts would be available in the Mono compiler. And so we worked with the folks at Xamarin. We convinced them to adopt Roslyn. And so we're kind of getting to this model now where the Roslyn compiler will be the single C# compiler and API in our ecosystem. There's a lot you can do with it. I'm not going to go through this in complete list. And then it almost becomes quaint that you can also use it for compiling. Certainly, that's where it gets used the most often, but these other scenarios are really exciting. OK, I talked a little bit about the other editors that are available. So there's this project called OmniSharp. It's an open source project. It's existed for 2 or 3 years. It's basically a server on top of Roslyn. And so all of these editors that you see on the screen, including VS Code, they have in-proc plugins that then talk to this out-of-proc server on the machine. You give OmniSharp source code, and then it gives you things like, you know, allowable sets of APIs given this particular type that the person is trying to use. So it actually works super well. I've used it in a couple of these editors, mostly in VS Code. The performance is really good. It does everything that you would expect. One thing when I first started using it that I was worried, okay, maybe they didn't quite go far enough, but like it even has IntelliSense within interpolated strings. You know, it just works. It's exciting. Okay, a little bit on philosophy. So as I said, C# is continuing to evolve, and so we've kind of had to think about what does that mean going forward? You know, we're kind of 15 years in, what does the next 5 or 10 years look like? The C# language is pretty large at this time. It's certainly mature. So we could say, you know, we did a great job. It's an incredibly capable language. Obviously, people can create incredible apps with it. Maybe we should be done at this point and just, you know, make sure our customers have stability and they'll be happy. So you can probably guess that's not actually what we're going to do. We see what's going on. There's actually kind of a bit of a language renaissance. You know, in that list that I showed you at the start, I referred to those other languages as niche languages. But that's actually where some of the most exciting language evolution is going on in our industry. And so we think that's great. But we also think that C# developers should have a bunch of those same features without having to leave C#. So we're actually going to, from a forward-looking standpoint, be a bit more on the side of aggressive with respect to language evolution than passive. So it's not just also about making sure that the folks in this room who maybe have been using C# for a while, that you get those language features. But we also want to make sure that new people will be attracted to using C# because the language has these compelling features in it. And last, you know, a bunch of the language innovation is focused on the workloads and programs that are topical for today. So, you know, we have this thing called Azure, for example. We want to make sure it's really easy to write apps that scale, that don't use so much memory, that start up fast, and C# is definitely a part of that story. And so our language innovation is definitely going to be focused on things like that and other things. I'm not going to go through this slide, just showing you that, yep, C# has been evolving for over a decade, for basically 15 years. We've actually built some pretty interesting features over that time, some of which have been industry leading, and we want this to continue. You know, when we get to C# 8, 9, and 10, and we're looking back at that 5 years from now, we want to be able to say, like, wow, those features we built in C# 8 and 9, they were impressive. Okay, we're almost to the demos. Yeah, so today I'm mainly going to talk about C# 7. There'll be some C# 6 pieces mixed in, but that's definitely not the focus. I just like using C# 6 because those features are great. You might wonder when C# 7 is actually coming. Well, it's actually co-developing with Visual Studio 15, as we call it. And so the latest version of Visual Studio 15 is Preview 5. That was released earlier this month. You can install it today. So far, like some people worry about the side-by-side thing with VS 2015 if you're doing production work. So far, it's working great for me. Earlier builds of VS 15 were definitely a bit more iffy. This one seems to be pretty solid. We'll also talk briefly about C# 8. There is work going underway there. I'm not going to demo anything because I don't actually have a working compiler to go show you those with, and certainly not a Visual Studio that works with that. But we'll talk about that. And another piece, which is kind of a philosophy strategy thing, is we've only really ever done these major releases, you know, the 1, 2, 3, 4s, 5, 6, 7, 8. And so there's kind of this realization that, you know, there've always been these small features that have had to wait until the big features were ready. So we're considering the idea of doing point releases. So imagine a 7.1 and a 7.2. It's something we're still playing with. We haven't really locked that idea yet. It has a nice benefit that you could get some smaller features, like, say, the interpolated strings that we did last time, earlier. The only potential downside is, as a business, if, you know, you've got 3 or 4 developers or 100 or 1,000, you would kind of have to make a decision as a group to either go on the point releases or not, because obviously the point releases would not allow new language syntax, and if, you know, the person next door wasn't using the new point release, then they couldn't use your code. So something to think about. We would like to get innovation out faster. It also aligns nicely with our, GitHub repository where there's a lot of activity going on every day. Okay, demos. Okay, so I'm going to get out of PowerPoint. Now, since we had those distractions with my machine not being set up correctly, Visual Studio is no longer set up. So let's see how we're doing. Okay, I want this to be empty. Okay, so what I'm going to show you is a few different features. Basically, tuples and pattern matching, I think, are the two, in addition to some C#6 features that we're just going to mix in. So the key point here is there's a NuGet package. Let's see. Oh, there we go. There's a NuGet package there called system.valuetuple. It's on NuGet.org, unsurprisingly. To do this demo, you need this NuGet package. Tuples don't work without it. Some of you might be a little bit surprised. It's like, you have language syntax that relies on a package on NuGet. Isn't that a bad idea? Kind of. This is really just a point in time. It's back to that kind of fast innovation. In the past, we versioned .NET Framework, Visual Studio, and the languages all together. We don't do that anymore. It means that we can get features out to you sooner. So this is kind of what this means. Probably in the future, ValueTuple will go into .NET Framework, .NET Core, Xamarin, so that you don't have to have this NuGet reference. But that's not where we are today. And I think that's mostly acceptable. Okay, so let's start writing this program. Okay, let's obviously make this bigger. And by the way, I'm good with questions along the way. Okay, so I'm going to walk you through this. So we're just kind of setting up the program. I am a big fan of using static, which is a C# feature. Okay. So we're going to set up our program. And public static void, okay, string array. Okay, so we'll very soon have, okay, syntactically correct, good. So what we're going to do, first I'm going to show another feature that I didn't even mention. So another cool feature is binary literals. This is probably not something most of you are going to use on a daily basis, but it's a nice addition to the platform. For some people, it's important. So you're probably familiar with this syntax. That's the syntax for hexadecimal numbers. Those have existed in the platform for a very long time, have existed in our industry for a very long time. So this is what binary literals look like. So it's very similar. It's basically just a different symbol or character there to show, let's make this a little bit bigger still, to show, there we go, it's a little bit big, to show what format they are. So let's make a few of these, just so you can see the pattern. So it's just an array. So they're binary literals, but they're going to be interpreted as integers. And so what some people like to do is do this. So you can actually put an underscore there, kind of like a comma. If you want to segment your binary numbers in a particular way, you could certainly do them on 4, as I've done here. And we'll just make one more just to, I keep on actually pressing O for some reason, which is not the correct thing. Okay, so we've got some numbers. And so what we are going to do is we're going to implement a method that does something with them. So let's see. We're going to call it tally, and it's going to take these numbers and love my hotfixes. You can maybe kind of see that. Yeah, what it's saying, obviously, is you don't have this method. Would you like me to generate one for you? Obviously, the answer is yes. And okay. Yes, that would not work well. Okay, we have a program that works. Obviously, first time I run it, it's going to throw, so that will not make anybody happy. What do you want me to do? Yeah. Oh, like this? Like this? No, I think you can put them anywhere. Maybe I'm missing the point, but and apparently you can make them really long too. Yeah, I think it's very freeform from what I understand, and apparently different people have different patterns that they like to use. Yeah, so I don't think there are any super strong rules there. We can mutate the program a little bit later just to see what happens, but since it's not working yet, we won't. Oh, jeepers. Thanks for catching that. Okay, so let's see what we're going to do. What we want to do is we don't really want to take object here. Well, actually, first, we have two choices here. We could, tally could return the sum of these numbers or the count. So what should I do? Does anyone want the count? Okay, does anyone want the sum? Okay, the sums seem to be winning it. So what we're actually going to do, and some of you can probably figure this out already, is we are going to do both. So we're going to do int sum and int count. And we are going to return, for the moment, this, and we will turn this into int array as well, just to make it better. And now we have, this is actually a working program, so let's actually just compile it once. And let's put a breakpoint here. Okay, let's see. There won't be any useful value yet. Okay, it ran. Yay! Okay, so these are tuples. So what this is, I think most of you can kind of figure it out, is it's a way of returning multiple values from a method. I think people have always wanted this. Now, we already have the tuple class in the framework. We've had that for like 8 years or something like that. The tuple feature, though, never had language support. And so I think you're going to see that the language support we've added is tremendously better than the tuple class that exists in the framework today. So now, let's keep on running with this. So the thing I think we want to change next is actually no, leave the t there. And this is going to be a tuple, int comma int. And then we are actually going to right line this value. And we'll use an interpolated string, since I love those so much. And we will say count is t dot, oops, let's close that. T dot, that's t. That should be correct. That's the type. Apparently I'm missing something obvious. I'm just going to put this for there for a moment, just in case it somehow magically fixes itself. Do you? Okay. Let's. Oh. I'm going to have to look back at my notes. There's something very obvious that I'm missing here. We could try that. Here, just a sec. So just in case, I actually practiced this several times. Just as a backup plan, you'll see how I use git. Let's see, cd/. Oh no, it's in users/me/documents. Yeah, just can't quite remember the syntax. Visual Studio. Okay, so here's what I do for my demos. So I'm going to git checkout step 1. Maybe this is step 1 or step 2. And that should have, oh, yes. No, okay, these are fun git commands. There we go. Oh, I see, var. Okay, well, we'll just go from here. Okay, so that's the part I was missing. Oh, we've already deconstructed it. We got a little bit too far ahead. Let's actually go back to the step before this. Oops. Already on step 1. Oh, let's go back to step 0. Oh, that was step 0. Okay, well, we're going to miss the step in between. Okay, let's see if we can get back to how this worked before. Oh, well. Anyway, we're skipping a couple steps in the demo, but that's okay. So the point here is that actually, oh, I know what happened. Right, so this probably before said var t. Yes, and then this. I don't know why that doesn't work. Okay, we're just going to go back to this. Okay, so what I really wanted to tell you is if you don't, if you just use, here's an example. Here, if we use t down here, oh, that doesn't work either. Something is not working correctly. Okay, well, basically the feature, the way it works is if you just do int, int, then you get a .item1 and a .item2 and a .item3 property. That's what I was wanting to show you. But you can actually instead use these names, and then you get the names instead. Actually, yes, and then that's called deconstruction. So the basic idea is you don't have to think of the tuple as a singular unit on it by itself. Instead, you can just deconstruct the tuple into component parts, and then you just use those component parts throughout your program, and it's all good. The tuple actually still exists. It's actually a first-class type within the system. These names are actually syntactic sugar, but they make it a lot nicer to use. Okay. So let's see what our program is doing. Okay, so what we did is we now have this method. It still takes an int32 of numbers. It still returns this tuple. Within this program, you'll see that I actually define another tuple. This isn't actually, so that I can then produce the tuple to return. And then we're going to for each on this list of numbers. And then we're going to do something with them. We're basically calculating the sum and the value. Now, I just want to say a couple of things here, which is you can see within the for each that we're actually creating a tuple every single time we go through the loop. And I think most developers probably think, like, I want to avoid exactly that kind of pattern. And the reason why this is okay is tuples are value types. So they're just created in on the stack in the confines of this method. And so there's nothing wrong with that at all. The tuples that we had in the framework system.tuple, I believe it's called, those are classes. And so doing that here would be bad. You'd be creating that memory on the heap. As that memory, as those type or instances were no longer needed, they'd be garbage collected, and that's not good for performance. These tuples don't have that characteristic at all, so it's completely reasonable to use them in this fashion. Okay, so how about we run this program and see what it does? I'll just show you what this is doing. So this is saying t.sum effectively plus v, v is the value. So that basically gives us the sum piece, and then comma t.c, that's the count, plus 1 because we just added another one. And then we return that tuple back to t, and then it's set, and then once that for each is done, then we return that back to the caller, which is the tuple. So let's take a look. Okay, all right. Since I did my git stuff, lost the breakpoints. Okay. Now you can see we've got a sum of 63 and a count of 6. For those of you that are familiar with binary, you can kind of see I've been a bit cute because these are basically just the first set of ones all added together. So that's why we get that particular number. Okay. So, yes. Okay, another feature. So we are now going to create a local function, which is another C# feature. It's somewhat similar to the way JavaScript works. You know, it has local functions, and people kind of create these like super nested programs, you know, that just go all the way to the right and then back down again. You will be able to do that with C# if you want. I'm not sure that's actually the best plan. You know, our vision of the way local functions is used is a bit more kind of surgical than that, but we'll see. So let's create an add method. So yeah, it should take int comma int, or yes, we do have to name them. And I think I will have to use different names. Let's see. And we'll give it a method body. And I think we can just put this in it. And we'll get rid of this. And then what we will do is we will then plus sum and plus count. And actually, I don't think we want this. Geez. Plus count. That doesn't actually make any sense. I might have to go forward again. This was going so well before when I was practicing it. Okay, let's see what we actually did. Okay. Okay, that's actually pretty much what I wrote. Okay, so basically what we did is we created this local function. It can go anywhere you want. So we're going to put it down here. And it's just a regular function. It basically just needs to be declared before the variables that it uses are declared. It's actually capturing this t in the same way that lambdas capture t's. From what I understand, it does it in a slightly more clever and better way. I can't actually explain to you what that is, but it works well. So let's run this method. Or, sorry, let's run the program again. And we should see that it does the same thing as before. Yep. So we're good to go. OK, so I think that is it for tuples. Now we're going to continue to mutate this program and get into pattern matching, which is where things get really interesting. I think most people probably just grok the tuples thing. So we are going to kind of wreck our little array here, and we're going to create an object array in the middle of it. Let's do these two. And we are going to need to change the type of this because now, there we go. Now it is, we don't need this. Yeah, now we've changed the contents, and we can actually even insert a null in there. So it's more kind of like disjoint, messy data, and pattern matching does really well with that. Okay, so now tally's wrong, so this now needs to take an object array. Okay, things are good. And now we're gonna go in here, and now we need to guard this add is implemented in terms of integers. So now we need to do a type check. V is int, and so we'll go here. And so now we know that that is going to be safe, but now we have another red squiggly, and why that's there is we did the type check to make sure v is an int, but now we still have to cast v to an int so that it's usable because we kind of lost the information of the type check in those two lines. Okay, so we can run this again, and you'll probably guess that we're going to get a different number than we got before. So now we're at 39, so we have to get back up to 63 because that's what we want, right? Okay, so what we're going to do is create our first pattern, which is, I think it's this. Let's see, int v, oh geez. No, it's something slightly different than this. Okay, let's go to, this is the reason I did this. Go to step 3. Okay, let's see. Okay, v is int, that's what I was looking for. Okay, so this, oh no, that's what we just had. We need to go one step further. Okay, now we've got a lot of comments here. Okay, this is what I was wanting to type. So this is interesting. So this is our first look at patterns. So this one actually takes a tiny bit of time to get through. The pattern is basically everything that comes before the I, and the I is what holds the pattern. So think of the v as int as a kind of constraint. That's how I think of it. And if that constraint is satisfied, then the data around the constraint goes into I. So I is both kind of the pattern and constraint and the resulting data once the constraint is satisfied. Hopefully that's not too mind-bending. So the real value of this is that I now is an integer. There is no type check, or sorry, no cast that needs to be done at that I below. And so we're basically doing two things at once. Like this, if that constraint isn't satisfied, then we never get past that if statement. So it's a conditional, but it also does this assignment to I if the condition is good. And then at that point, we're kind of type safe because we know for sure that I is int and the rest of our program will run correctly. Hopefully that makes sense to folks. So let's, yeah, we don't think we need to run this again. Okay, so now what we're going to do, is there anything else I said here? No, that's basically what I just said. This last point, which is pattern matching is kind of like a whole space. What we're doing, and I'm going to show you a couple more, is still pretty much the basics of it. This is something we're going to kind of work on and evolve over multiple years. I don't think we probably know all the patterns that make sense to have. That's your feedback that probably will help us get there. But yeah, so this is more the beginning than the end for sure. So let's make this a switch statement. So in the past, as I imagine many of you know, you couldn't switch on anything but primitives, which was a pain. You know, you could switch on bools, you could switch on ints, but not many other things. Now you can switch on anything, including patterns. So, okay. Yeah, okay, let's go to the next step. Okay. This is the syntax. Okay, so this is the same thing as what we just saw before. It's just a slightly different syntax. So now int I is the pattern. Yeah, we didn't really need the other text, of course, now that I'm thinking about it, because V is already, we already have V at the top. So all we have to specify is the int I part. And so if V can be essentially, if V is an int, then the value of V will be put into I, and then we'll run this code. So it's the exact same thing we had before. So now this is the point where it gets really interesting. So let's add another case, which is, should be object array O. So we could just leave it there, break. Yes, okay. But, so this is the object array that's above that we want to process and do something different with. But we're actually going to add, we're going to make the condition even more specific. When O.length, this is what it's supposed to be, is greater than 0. Okay, it's happy with that. Okay, so what this is saying is, I don't want to process any object arrays that don't have any elements defined. So I know I have an instance by virtue of object O, but I can further constrain the pattern so this code never gets hit. And so what we're going to do is we're going to, in this case, we're going to recursively call tally with O. And so that will give us this. That will give us a, that's right, the same thing as we had up here, right? So we can do this, and we're going to make, we'll make it called Summy and County, because I need to come up with different names. And then we can do add Summy and County. Bear with me on my names. And I think now if we run the program, we should get the correct values again. Let's see. Let's see how we did. Yep. Now we're up to 63 and 6. And I think that is, let's see, I think that is the end of this demo. Does anyone think this is cool? Can anyone see using patterns and having a better switch statement? Okay, let's just take a quick look. See how many branches I had. Oh, okay, apparently there was a step 6. Let's see what's in there. Has anyone ever used Git this way for demos? I do this fairly often. Yeah, that's what we just wrote. Okay, that's that demo. Cool. I want to show you something else. This one's much shorter. Let's see. Bouncer pattern. And then we need to do a couple more slides before we run out of time. Okay, so this one is, yeah, so there's this pattern called bouncer pattern. I actually use bouncer pattern all the time. I really dislike writing code where I write these if statements at the start to basically validate the information that's coming in. And then all my code kind of goes to the right. And then I kind of have to deal with that for the rest of the method implementation. So typically don't do that. I write these conditions at the start, and then only code that gets past those conditions is kind of good. I throw exceptions or something at the start, and then my code is all the way left aligned, and I'm happy. So that's kind of what this pattern is. And so patterns actually are helping with people who like that pattern. So this is kind of bouncer pattern-ish, which is the first call here does pretty well with it. Basically says if O is null, throw this exception, and we're right back to the left. Here, we've got more of a problem. So we say O is point P, this is a pattern, and then you would think that you have to then deal with P inside the if statement. So turns out that's actually not true. So the scoping rules are actually different with patterns than they are with regular expressions in if statements. So actually what we can do is this. You should like this. So let's do this. Let's put a not here. And then let's grab this text. Let's put it here. And do that. Obviously get rid of this else. And we're good to go. So now the proof is this. Okay. Okay, don't know what's happening. What I'm wanting to write, okay, I think Visual Studio just crashed, which wasn't the plan. Actually, I've been using it quite intensely. This is the first time that that's happened. Visual Studio Preview 5. Bouncer pattern. Okay, I did that. I'm just going to, for the sake of moving this along, I'm going to do that same technique because we're going to run out of time. Bouncer pattern. Okay, so get branch. Okay, get checkout, step 2. Well, it's fast enough. Okay, so let's just repeat this. Okay, do this. Okay, obviously we need the not here, otherwise the program wouldn't do what we wanted. Okay. Huh. Okay, there. Oh, wow, that's weird. Okay, so what I wanted to, okay, something's very wrong. What I wanted to type was this, another interpolated string, point, x is p dot, something's really wrong with my Visual Studio. P dot x, and then y is p dot y. No idea why those aren't working. Okay, you're just going to have to take my word for it that these, that they should be, but that's not. Oh, okay, interesting. I think there's something wrong with IntelliSense. Yeah, this was working awesome for me before. Okay, so basically what this is showing is when you do patterns, the variables that you create escape outside of their natural scope, and then they're usable elsewhere. Another thing I want to show you that's related to this is, let's look at this method. Oh, man. Okay, let's use this trick again. We'll go all the way to the end, and then I can just speak to it, because that is not working. And we just have to do, okay, spelled that wrong. And it's step 3. Okay. Wow. Okay, so here. What? Sorry, folks. Okay, well, I'm just going to have to type this. Oh, here it is. So there's another feature called outvars. So you're probably familiar with when you call a method that has out parameters, you probably have done things like this, which is var x like this, and var y, and then done this, that kind of thing. So anyway, you don't have to do that anymore. You can define variables that are outs at the point of calling them, and these two also escape out. So we can actually put x here and y here, and that also works. So that's a nice new feature. It's very similar in feel to these other features. So you can see we're just trying to bring you a tiny bit more convenience and use these features together. Okay, let's go back to the presentation. Those were the demos. Hopefully people are excited about those. Okay, let's quickly talk about this one. Very few people in the room will probably use this. We've had refs and outs that you can use as parameters. We now have ref returns as well in C#. And so the basic idea is, like in this particular example, this getAsteroid method, it takes a position, and then what it's returning back is an asteroid. So imagine, so what this returns is imagine it's an asteroid struct. And so both this method and its caller are sharing the exact same memory. So there's actually no copy of the struct as it goes across this boundary. So really where this matters a ton is in games. So we talked about Unity before. Imagine you're doing something, the game is running at 60 frames a second. It's touching 1,000 asteroids on every frame. If you can avoid those copies and avoid getting the GC upset, then that's a great thing. So that's what this does. Most of you won't use this. I'm not going to show this example because we're quickly going to run out of time. So yeah. I wanted to show you this. So this is all for future looking. So this would be more like C#8. This one's kind of fun. So it's another pattern, but it's kind of just going a little bit further. So let's walk through it. So the first part is exactly the same as what we saw before. So it's O is point. But then it's a question of what it's going to get assigned to. So then we have these, the thing that either looks like a method call or a tuple. It's actually a tuple. It's not a method call. And what it's saying is, first, O has to be a point. Second, X has to be 5. So the 5 is a constraint on the X value. And then it's saying, for the Y value is unconstrained. But if everything else is met, then assign the Y value to Y. And then that's what's printed out. So we only get past the condition if all that's true, and then Y flows to the rest of the code. So I'm not sure exactly what the particular use case is, but I can kind of imagine it. It's just basically a way of more compactly describing conditions. There are other languages that have these same kind of techniques, especially from functional land. And we want to have some of these too. So this one's really fun. So this is a match statement. This is kind of like a, something kind of switch ++. And so this match takes a tuple. So the tuple is, in this particular case, it's about a door system. And so it's saying there's the state that the door is currently in, and then there's the request of what someone wants the door to do. And so we'll just go through a couple of these. So it's basically saying, if the tuple is closed open, then what I want you to do is open it. And then on the very bottom, if the door is currently locked, and I want it to be unlocked, then move it to the closed state. I'm not sure I completely get that one. But the kind of attraction to this sort of pattern is it almost starts to look like not code. It starts to look very declarative in nature. And so, just a normal human can kind of look at these almost as business rules and quickly identify whether there's a bug. I mean, you don't really need to know anything about computer science per se to interpret that. So we think that's great. This is another kind of functional language-esque thing. Another thing that we're kind of playing with, and a bunch of people in the room might squirm at this particular one, is nulls and nullability and immutability are all things we've kind of been playing with over the last few years. F#, for example, is a bit different than C# in this respect. And so, and there's this idea like the introduction of null is this like $300 billion industry mistake, which probably is true actually, given how many null reference exceptions we've all seen. So the idea here is, imagine we had this new symbol, the question mark, and that was the thing that said, I am allowing this thing to be, the variable to be null. Now, and then the lack of it would mean that it's non-nullable. So there's probably some folks in the room who are saying, that looks like a breaking change. This would be. It would have to be a compiler opt-in for people who wanted to live and breathe this lifestyle. So something we're thinking about. I think what the next step is we kind of have to prove that, demonstrate that a set of programs that were written this way or that were migrated from the old system to the new system basically was tremendously more safe, potentially had better performance, and found bugs. Because I'm sure we all have null reference style bugs in our code. So this is just saying assigning null to n totally works because you've opted into that. Assigning null to s and assigning n to s doesn't work. It's possible we would just make this a warning as opposed to an error. That's the basic idea. Right, and it's basically saying when you use these things, in one case, you know it's not null because of the character, because of what the language gives you, and then in another case, it could be. So we could also be clever and say, we know that n is an object. It has an object instance because of this check before it. Obviously, multiple threads, blah, 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 but so the compiler could help you that way too. Async streams are something that the team is playing with. When async first came out, it works super well for single values, but I think many of us, the very next thing we wanted is like, I want an async IEnumerable so that I can for each, and I can kind of slowly provide values when I'm asked for them from an async IEnumerable. So that's basically the idea. And there's a few different places in the language where that could work out. Don't really have time to go into this. This particular one is, this syntax looks very attractive. It's basically a super compact way of describing a class declaration and its primary constructor. It's also potentially the syntax for describing records, which is another feature that we've been working on, or at least thinking about. This record idea is kind of like a value class sort of thing, where you can see that the values would be immutable. They would have deconstructors. Deconstruct, which I didn't really talk about, is a custom way of enabling your value to be deconstructed in that same way that we showed with sum and count earlier. So anyway, there's this basically almost like a new type lifestyle that we're thinking of enabling with this, and that would be the syntax for it. So the struggle is there's two different things that we might want to do with the same syntax. Both are super valuable, and we don't know which one. So until we figure that out, we're probably not going to ship this feature in either form. OK, that's pretty much, I think, right on time. Again, this is my contact information. Does anybody have any questions? Yes, sir. That's a good question. I am actually not sure, which I think some of them are. Yeah, I don't have that information. Oh, the question was, are all these features going to be on VB on day one? And I just actually don't know the answer. So I'm actually not on the C# or VB team. I'm on the .NET team. So the C# VB interaction is something that I'm not 100% certain of. I'm pretty sure some of these are, but I'm just not sure which ones. It's a good question. Yes, sir. Sure. Yeah, I could post all of that to my GitHub account later today, which is the Rich Lander one. For sure. I could probably actually do it right after this talk. So it would be github.com/richlander. And I would name the repository something intelligent. Or I might actually just push up both the repositories as is, since they're two different repositories. Any other questions? Just while I have everyone in the room, I just want to see a show of hands. Do people like this direction with C#, these kind of features, and kind of fairly aggressively evolving it in the future? Or put up your hand if you want us to basically close up shop and call C# 6 good, and that's all you're going to get. OK, maybe one person. OK, anyway, that's not what we're going to do. Thank you so much. Appreciate it.